Okay, so we're going to go ahead and get started. I just want to do a quick, brief intro about what the point is of balancing chemical reactions. So, if you will remember back in the day when we were back in school doing things regularly, we did a chemical reaction where you made the yellow precipitate. And remember, the whole point was we were trying to make what we put in equal what we got out. Okay. So that's what's happening now is now we're just doing this on paper. Okay. And I'm sorry about the bing bonging, but I'm having to put everybody in a waiting room now because there's some skeevy people out in the world that have been coming into Zoom sessions doing some pretty inappropriate stuff. And so they suggested we do passwords and waiting rooms. So that's what we're going to do. So anyway, I just want to kind of briefly discuss what a chemical reaction is, the point of balancing them, and then we're going to get into practicing some of them and look at a few different types of them. When we balance chemical reactions, we're doing it because we're trying to satisfy the law of conservation of matter, of mass or energy. Basically, we're saying whatever we put in has to equal whatever we get out. And so I put here a basic chemical reaction for the production of sodium chloride or table salt. So we put in sodium, we put in chlorine, and then it yields or produces sodium chloride. This side of the arrow is what we call the reactants because these are the things that are doing the reacting. On the head side of the arrow, those are our products because that's what we're producing, okay? Now, one way to do this, but I don't suggest that you get into a rut of doing it because it starts taking you a lot longer to balance reactions. But to get you started, this is a good idea. Um, in your unit plan, one of the first things that we have, and I'm going to show you real quick. Let me share my screen. Um, So you should be able to see my screen right here. Under classwork, you'll see the Unit 5 plan, okay? So this, of course, is our plan and what we're doing during this unit. If you look, it's a fairly short unit. Right here, this Chem Unit 5 intro worksheet, this is basically taking you through a step-by-step of how to balance chemical reactions. So if you've not done this yet, I suggest that you do this as soon as we get finished, just to kind of give you a little more practice, okay? Also, for those of you who feel pretty confident in this and you're like, hey, I can do this, I just need more practice, there is tons of practice problems right here. There are tons of them that you can just download and you can work those out on pieces of paper.
Are they
Okay,
for a grade?
what's that?
Are they for a grade?
The only ones that are for a grade are the ones that are listed as assignments. Those are just extra practice so that way you can make sure you hone your skills. Because I'm going to go ahead and warn y'all, if we do get to go back to school on the 20th, we're going to hit the ground running. We're taking this and we're putting stoichiometry with it, and we're going to go from there. So the more you know how to do this, the better you feel about this, the better it's going to be when we go back to school finally. Okay, so let's talk about how you would balance these, okay? So right here, I have counted up how many of each one of these reactant atoms that I have here, okay? So you'll see that right here I have 1 sodium and I have 2 chlorine. That little 2 subscript tells me that there are 2. On this side, you'll see that there's only 1 sodium and there's 1 chlorine, so 1 and 1. So my sodium is going to equal, but my chlorine does not equal, and so this causes a problem. We are not satisfying the law of conservation. So that means that I have to go about balancing this. Now, there is a rule that you need to make sure that you follow always. We never, ever, 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 ever change the subscripts, these little numbers behind, okay? When we balance a chemical reaction like this one, we don't change anything about these individual atoms or individual compounds. We can only add what's known as a coefficient. A coefficient is a number that we put in front of the different parts of our chemical reaction. So right here, I see that I have 1 sodium and I have 1 sodium. So they're equal. But on this side, I have 2 chlorines, and right here, I just have 1. So I need 2 on this side. So to do that, I have to put a 2 in front of the entire compound. We never put a coefficient inside the compound. We never add a subscript behind it. It has to go in front. So now I go back and check. I have 1 sodium here, and I have 2 sodiums here. So now sodium doesn't balance. So I've got to go back over here and put a 2 in front of this sodium. So 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines, because this 2 distributes to both of them. So now it is balanced. And I did that by adding the coefficient 2 in front of sodium and sodium chloride. Okay? All right. So let's just work a few problems. And then after we've worked 2 or 3 of them, you can ask some questions. Okay? So let me pull up another piece of paper. Okay. So I'm going to be looking at this worksheet, which is one of the ones that is put under the unit plan. It's called Balancing Equations. I think it's like Balancing Worksheet number 1. This one is not a grade, but I thought we would use it for practice. So this is where I'm getting these problems from. So I'm going to start by doing the first one. I have a CH4 plus O2 yields CO2 plus H2O. So this is our chemical reaction. Okay, so I start with my carbons. I have 1 carbon here and I have 1 carbon here. So carbon is okay. And then I'm going to look over here at my hydrogens. I have 4 hydrogens here and I have 2 hydrogens here. So that means that my hydrogens do not balance. So if I have 4 over here, I need to do something to this H2O to make this 4 hydrogens. So to do that, I'm going to put a 2 right here. So that means I have 1 carbon, 4 hydrogens, 4 hydrogens. So now I go to my oxygens. I have 2 oxygens here. There's 2 here, and because I put this coefficient of 2, that means there's 2 here. So 2 plus 2 means I have 4 oxygens on this side. So I need 4 on this side. So to do that, I put a 2. And then I go back and check the whole thing again. 1 carbon, 1 carbon. 4 hydrogens, 4 hydrogens. 4 oxygens, and 2 plus 2 is 4 oxygens. So now it is balanced.
Can you move it to the left a little?
That way?
Yes, ma'am, just a little bit more. Okay, thank you.
Okay. You're welcome. Okay, so it's really not hard to do. You just got to get good at it by practicing. Okay, so that's what we're going to be doing is we're just going to practice several of these. Then we're going to talk about types of reactions and then we'll be wrapping up. Okay, so let me put another one down here for you. Okay, on this one, we're going to do, let me get me a darker marker. Sodium plus iodine yields sodium iodide. Okay. So what I do is I start with my sodium. I have 1 sodium here and I have 1 sodium here. So they're balanced. But then I go to my iodine. I have 2 iodines here and 1 iodine there. So they're not balanced. So to balance it, I have to put a 2 in front of the entire sodium iodide compound. So now I have 1 sodium, 2 sodiums. So I need to come back and put another 2 right here. So that's 2 sodiums, 2 sodiums, 2 iodides, 2 iodides, and now it is balanced. If you'll notice, every time I add a coefficient, I always go back and check again. I start back at the beginning because sometimes when you add in a coefficient, it messes up what you originally thought was okay. So you do a lot of rechecking yourself when you do this, okay? So I want y'all to do this one. We're going to do nitrogen plus oxygen yields dinitrogen monoxide. Okay, so take a second and I want y'all to balance that one.
Miss Fortenberry.
Yes, ma'am.
I have a quick question about on both of the videos that we had to watch. One, the first guy he did polyatomics, but the second guy didn't. Which one would you recommend do?
You're going to do both of them. So
Oh,
I
right.
would start with monatomics and then go to polyatomics. We're going to work a couple of polyatomics in just a second, and I'm going to show you how to work those because they're really not hard. So I'll
Okay.
show you how to do those. We're
Okay,
starting.
and I'm sorry.
That's fine.
And also what we're really getting confused about is like no, okay, right. It's like on the oxygen ones, the one that has like number 1.
Hmm?
Yeah, if it's like they have it more than one in a problem.
If there's more than one oxygen in a compound, you add them up as a total.
Mm-hmm. And do you I think it was the second guy, he did it, and it's like what he did was he multiplied, like he had 2 oxygens. I'm trying to think how he did it. He like multiplied first, then added the other oxygen that was
And
over.
you can do that. That would be like right here. I say 2 times 1 is 2.
Yeah.
Plus 2 is 4.
Yes. That okay.
So, yeah.
Okay.
That's all that is. No problem.
Okay.
Okay, so let's look at the answer to this one. I have N2, so that's 2 nitrogens and 2 nitrogens, so that's good. I have 2 oxygens and 1 oxygen, so I need to make this 2, so I'm going to put a 2 right there. So now that gives me 2 nitrogens and 4 nitrogens, so that means I have to come over here and put a 2. So that's 4 nitrogens, 4 nitrogens, 2 oxygens, 2 oxygens. So now it's balanced. If you got that, give me a thumbs up. Good job. Good job. Okay. So so this is just the basics of how to balance an equation, okay? All of these are monatomic. They're pretty easy to see what's what. Now, the Roten squared mentioned, what about with polyatomics? Because polyatomics can be a little confusing. So I'm going to show you a polyatomic one, and we're going to work through it. I'm going to show you a quick way of doing it because I know on the video they do something a little bit different, but I have a better way, okay? So let me move this piece of paper, and I want everybody to write this one down. So that way you'll have it to go back and look at as you're going through these different problems on your own, okay? So we're going to work, this is actually number 15 on that balancing equations worksheet. So number 15. So we have magnesium nitrate, MgNO3(2), and we're adding it to potassium phosphate, and we're going to get magnesium phosphate plus potassium nitrate. Okay, I'm sorry about all these chords. There we go. Okay, so take a second and write that one down. And then I'm going to show you how we do this one to make it a little easier. So there's two ways that you can do this. One way that you can do it is that you could break apart each individual element and get the totals of each, which means you have 1 magnesium, 2 nitrogens, and then that would be 6 oxygens right here, then 3 potassiums and 1 phosphorus and 4 oxygens here. So you'd have to add those together, which would give you 10 oxygens on this side. Then on this side, you could do the same thing, each individual element, but that's a lot of work and nobody likes to do extra work. So I have a better way of doing it. This is a way that a teacher taught me, and it's so much simpler. So I'm going to show you what they taught me. So the thing is, when you have a polyatomic, the only way that this trick works is if the polyatomic is the same on the reactant side as it is on the product side. So that's what I have to start off by doing. So I look and I see NO3 right here, and I notice there's an NO3 on this side, okay? And then I see PO4 on this side, and PO4 is on that side. So right there, I know that my polyatomics remain intact on the reactants and the product side. So instead of splitting them apart into individual elements, nitrogen and oxygen, phosphorus and oxygen, I'm going to keep them together as a unit. So I'm going to balance it just like I did with those monatomics, but I'm going to balance the polyatomic and treat it as one unit, okay? So let me see here. Let me kind of zoom out there. Okay, so I have 1 magnesium on this side, and I have 3 magnesiums on this side. So I need to come over here and I need to put a 3 in front of this magnesium, okay? Now, I'm going to look at my nitrates as a whole, okay? So looking at this nitrate, I have 2 of them in the compound, and I just put a 3 as a coefficient. So 3 times 2 means that I have 6 nitrates, okay? So now I can go over to this side, and I look over here, and I see I only have 1 nitrate. So I'm going to put a 6 there now, okay? So now I have 3 magnesiums, 6 nitrates, 6 nitrates. So now I'm going to go to my potassium. I have 3 potassiums on this side, but over here I have 6. So I need to come and put a 2. So I have 3 magnesiums, 6 nitrates, 6 nitrates, 6 potassiums on the left, 6 potassiums on the right. And so all that I'm left to do is the phosphate. So that 2 in front of potassium phosphate tells me that I have 2 phosphates. And then I look on this one and I have 2. And so just to double check, 3 magnesium, 6 nitrate, 6 nitrate, 6 potassium, 6 potassium, 2 phosphate, 2 phosphate, and it is balanced. Isn't that simple? That's not bad, is it?
Is there like a certain way you want us to work these, like write stuff on the bottom, or do you just,
No.
is it okay?
You can do it however you want to. I know some people like to take the long route, like on that introductory worksheet. And then there's some people like me who like to just play with it like this. So you don't have to show work on this necessarily. You just need to balance them. And so I kind of give you free reign. There are some students who like to write out every single element that's in there because that works for them. If that works for you, you go right on ahead. But if you're like me, you don't need to do that. I get more confused when I do that. So I do better just playing around with it. And I'm going to go ahead and tell you right now, I've been balancing equations for a very, very, very long time. I started doing this when I was in junior high, and so we're talking 25 plus years that I've been working on this. And there are times where I will sit there and try to balance and try to balance and try to balance, and it just will not work. And I'm like, I can't do this. If we were sitting in class, I guarantee you that we would have questions on some, and we would put one up, and I could not get it to balance. And I'll say, okay, somebody else do this one because I can't get it to work. Sometimes you have to step away and come back. I tell people to think of it like a puzzle. It's a puzzle. And so sometimes it'll work really easily. Sometimes you have to set it down, come back, and then start on it again, okay? Now, there are a couple of rules that I need to go over with you that I want to write out so that way you'll know, okay? So when you're doing equations or balancing our equations, one thing that you need to remember is that coefficients must be simplified. So what in the world does that mean? Okay, so let's say that I have balanced that very first reaction that I gave you on the very beginning, NaCl2. And let's say that I have balanced it like this. 4 Na2Cl2 yields 4 NaCl. And it's balanced. 4 sodium, 4 sodium, 4 chlorine, 4 chlorine, everything's balanced. But what do you notice about 4, 2, 4? What
It'd be
can I
2,
do
1,
to
2.
That's right. I can reduce this by taking out a 2. So instead of 4 Na2Cl to 4 NaCl, I need this to be 2 Na plus Cl2 yields 2 NaCl. Okay, we have to make sure that it is reduced. So this is correct. Oops. This is not correct. Okay, you can't do one that is not simplified. Okay, so does that make sense to everybody? Same thing we did when we were balancing our chemical formulas. We just have to make sure our coefficients are simplified. Okay, number 2. Every now and then we will have a equation that is already balanced. When an equation is already balanced, write, whoops, BAL beside it. So let me see if I can give you an example of one.
There was one on this worksheet, I think, from the introduction one.
Okay.
Let me see. It was number 8.
All right, you want to give me the equation?
What's that? Barium, sulfur is all together.
BAS
Plus PT, platinum.
PT
F2,
F2
yield.
yields
Barium fluoride 2.
BAF2.
plus PT platinum sulfur.
Okay, so let's look at it. 1 barium, 1 barium, 1 sulfur, 1 sulfur, 1 platinum, 1 platinum, 2 fluorines, 2 fluorines. You're exactly right. So I'm going to write out to the side BAL. And the reason why I do this is I know you looked at that one and you know it's balanced. If you don't write that, I'm just going to assume that you skipped it. Okay, so you need to make sure if there's one that's written and it's already balanced, you write BAL. Okay. Okay.
I have a
So
question for that sodium chloride.
yes.
Because I'm kind of confused and getting kind of aggravated because, like, on one side it says like Cl2, and then on the right side it says like NaCl and with no subscripts. So,
Okay.
like, is it?
So let me explain why we have subscripts and not subscripts. This is an actual compound, chlorine in air, Cl2. If you made that Cl, it wouldn't be chlorine in air, it'd be something else, okay? And we know, because we've already learned how to balance formulas, that NaCl, that's a +1 and a -1, okay? So whenever we write out a chemical equation, the first step is we have to make sure that all of our charges equal out. And we're fixing to talk about why this is Cl2 in just a second, okay? All right. So when you're balancing a reaction, you never, ever, ever touch your subscripts. You leave those alone. If those are balanced correctly, then you never mess with those. The only thing you're allowed to do is to add in coefficients. Okay? So the reason why this number has a 2, or this Cl has a 2 and this one doesn't, is because this is a different kind of compound than this one. Right here, it has to have a 2 to be balanced. Right here, it does not to have a 2. So your job is to balance it with coefficients. All right, so let me show you why this one has a 2. So this is something that some teachers talk about whenever we're doing chemical formulas. I typically don't bring it up until we get to reactions because it's not really a big deal until we get to reactions. So over on the side somewhere, you need to write this down. This is called diatomic molecules. All right. Diatomic, anytime we see di, we know that means 2. So this is 2 atoms within a molecule. There are 7 elements on the periodic table that can never be alone. Okay. I tell students it's kind of like girls when they go to the bathroom. For some reason, they need a friend. Okay. And so these elements have to have a partner whenever they go somewhere. Okay. So I had a teacher who told me this acronym. It's not the most, what's the word? I don't know how appropriate it is for high schoolers, but in college it worked pretty well. Okay. So here is the acronym. Have no fear of ice cold beer. Okay. Have no fear of ice cold beer. The top letter, or the first letter in each one of these, tells us which elements are diatomic. So have is hydrogen, H2. N is nitrogen, N2. Fear is fluorine, F2. Of is oxygen, O2. Ice is iodine, I2. Cold is chlorine, Cl2. And beer is bromine, Br2. And I don't know which teacher told me this. I think it was in at Southwest, maybe Ms. Guy. But it sticks because it rhymes. How many of you had learned this if you took Miss Russell for honors physical science? Do y'all remember this slogan? Yeah. Yeah, I think she uses the.
We did Funkleberry High.
Yeah, but we also did that one though. But
Yeah.
we did Funkleberry High too.
I don't know Funkleberry High. This is the one they gave me. So, and it works because I can remember that saying because it rhymes. And so what happens is anytime we're working a chemical formula or chemical equation, like the sodium chlorine, so this kind of answer your question, Robert Cole, when we were dealing with sodium chloride, Na plus Cl2, the reason why this is Cl2 is because it's a diatomic molecule. Okay, and then that gives us NaCl. And this has to be NaCl because that's a +1 and a -1. So we have to balance our charges. Okay, so that's why we have a 2 on this one, but not on this one. Because right here it needs a partner to go to the bathroom. Right here it has a partner. Sodium's coming with it. Okay, so whenever you're working problems, like on this worksheet, for instance, you will notice everywhere that you have like these little Cl2, I2, whatever, those are diatomic molecules, okay? So if you have to do a word problem that asks you to write out the chemical equation, you need to remember that these 7 elements have to have a partner, okay? Does that make sense to everybody? Okay, so there's one other thing that I want to talk about real quickly, but I'm not going to go really in depth into it because you can go in and watch it on the Google Classroom, and then we're probably going to do another Zoom session later on and just kind of do a quick review. But I want to show you on your classroom. When you go to the classroom, you're going to see classifying chemical reactions, and on the unit plan right here, on day 2, you'll see, I'm sorry, day 1, you'll see types of chemical reactions, okay? We have 5 types of chemical reactions that we learn in this class, okay? So we have synthesis, which means we're making something. Okay, so synthesis means we're making something, and that would be like our sodium chloride. So Na plus Cl2 yields 2 NaCl. This is a synthesis reaction because we're putting something together and we're making it, okay? So another type that we have is decomposition. Now, just looking at that word, what do you think decomposition would be? Yes, Sierra. She showed taking it apart, okay? So 2 NaCl yields 2 Na plus Cl2. Now we're breaking it apart, okay? So these are the exact opposite of one another, okay? So our next type is single replacement. Single replacement, I tell people, think of a dance. Okay, so one that's a good one is Ki, potassium iodide, plus chlorine, and it yields potassium chloride plus iodine. Okay, so basically potassium and iodine come to the dance together, and potassium sees chlorine, and he's much more interested in chlorine than he was iodide. So he runs off with chlorine and leaves iodide to the side. Okay, so when you do these, just remember that positive always goes with negative. Okay, so you're not going to have chlorine and iodine run off together. It's going to be chlorine and potassium will run off together. Okay, and then you would need to balance that one. Take a second and balance that one for me. Did y'all get that? All right. Okay, and then the fourth type is called a double replacement. And for both of these, sometimes you'll see people call them single displacement. You'll hear me say them both because I've learned them both ways, but it's the exact same thing. So on this one, it's basically like you have two couples come to the dance together and they decide, hey, let's just swap partners. And so let's see, this would be a good one. Calcium sulfate plus aluminum bromide. And that's going to give us calcium bromide plus aluminum sulfate. Okay, so calcium and sulfate showed up together and aluminum bromide showed up together, but then they swapped partners. Take a second and try to balance that one because that's a good polyatomic balancing. Did y'all get that? Good job. All right, and then the last type of reaction is called a combustion. And combustion reactions all have a very general equation. You are going to have a hydrocarbon of some sort. It could be CH4, it could be C2H6, it could be C3H8, it could be anything, a hydrocarbon. It's always going to have an addition of oxygen, and it will always equal carbon dioxide and water. Oops. And water. This is a combustion reaction. One of the first ones we did today was a combustion reaction. So CH4 plus O2 yields CO2 plus H2O. And then that balances that. Okay. So does anyone have any questions so far? Okay, I also want to tell you one other trick. If sometimes you have balanced and balanced and balanced and balanced and you cannot get it to work, maybe it's especially on combustion reactions, this tends to happen. Let's say that you have balanced it and you cannot get this oxygen to equal out like you need to. A trick of the trade is go back and erase all of your coefficients and start by putting a 2 in front of the first one, okay? And then try balancing it that way. And if the 2 doesn't work, go and erase it and try a 3. And if the 3 doesn't work, go try a 4. Now, if you get up to 15 plus, you've probably written something down wrong or you just need to take a step away. But the more that you practice these, the more that you hone your skills, the faster you're going to become and the easier it's going to be for you, okay? So does anyone have any questions before we wrap up?
Can you work number 12 on the worksheet that you were looking at earlier that you were getting stuff from?
Yeah, hang on just a second. Let me get another sheet.
I couldn't solve that one to save my life.
Okay. All right, so we have number 12, H2O2, which is hydrogen peroxide, and it breaks down into H2O plus O2. So this is a decomposition reaction, okay? So I have 2 hydrogens and 2 hydrogens. I have 2 oxygens and 3 oxygens. So I'm going to come over here and start by adding a 2. Let me just see if that works. And then that's going to give me 4 hydrogens there, 4 hydrogens there. And now I have 4 oxygens, and 2 plus 2 gives me 4 oxygens, and that balances it. So anytime that you have trouble and you can't get it to balance and you're just about ready to throw it across the room, go stick a 2 in front of the first one. Okay? And you are going to find, I'm going to go ahead and just tell you now, you are going to find from time to time, no matter what you do, there's going to be one that will be so simple to somebody else, but to you, you just can't get it. And you're just going to have to sit down and take a step away from it and come back to it. If we were in class, that is exactly what I would tell you. I have students that'll come and go, Miss Warbury, I cannot get this to work. How do I get it to work? And I'll say, go sit down for a few minutes, leave it alone, and then come back to it, and then it finally kind of reveals itself. Okay. So does anyone have any questions other than that? Okay. Well, I'm going to stop recording right